In the first video, we discussed about the refraction of light into different mediums, rarer to denser and denser to rarer. Now, in this video, we'll continue the remaining topic. In the first lesson, we have one derivation to find out the image formation for the focal length and object distance and the image distance. What is the formula for that? 1 by f is equals to 1 by v plus 1 by u. Now, in this refraction of light, we have one more derivation, but that derivation part in our textbook, they are given in the blue pages. So, the content which is given in the blue pages, it is not necessary to learn. So that's why this content I am not explaining. Just we'll find we'll find out what is the formula for the refraction of light to find out the image formation when the refraction takes place at curved surfaces and the refraction takes place at plane surfaces. Once again I am repeating. Here we have one derivation. Here the derivation for to find out the image formation. So that image formation, when we'll get the image formation, when the light refracts at curved surfaces, or otherwise when the light refracts at the plane surfaces. For example, when the light refracts at a curved surface, here you see, when a light ray enters, here I wrote 2 times, enters a medium with refractive index N2 from a medium with refractive index N1. Here refractive index N1 and N2 I use, means 2 different mediums, and that mediums are having the refractive index values. What is the meaning of refractive index? Refractive index is nothing but we are comparing the speed of light with the vacuum. The speed of light we are comparing with the vacuum. Suppose when a light is traveling in air, so the speed of the light we are comparing in air, we are comparing with the vacuum. So that comparison of the speed of light with the vacuum is known as, vacuum to that particular medium is known as refractive index. So for the refraction means at least we required, not at least, we require 2 mediums, air medium, water medium, glass medium, like that. So here one medium will take it as N1 and another medium will take it as N2. When it refracts from one medium to the another medium, if it refracts at curved surface, refraction it takes place at 2 surfaces, plane surfaces and curved surfaces. So if the refraction takes place at curved surfaces, for the image formation we have this derivation. What is that derivation? N2 by V minus N1 by U is equals to N2 minus N1 by R. N2 minus N1 by R. This is the formula for derivation of an image when the refraction takes place at the curved surfaces. Here in exams they may ask the question, write the formula for the refraction of light at curved surfaces and explain the terms. For 1 mark or 2 marks they may ask mostly. So here this is the formula, you have to write it, and here N1 is the refractive index of one medium and this N2 is the refractive index of another medium. V is always image distance and U is always object distance. Here curved surfaces. Curved surfaces means these curved surfaces are having the radius of curvature. They are having the radius of curvature. So sorry, this is known as radius of curvature. So the R is radius of curvature. Here I wrote all the terms. Suppose when the refraction takes place at the plane surfaces, then what is the formula? For this we have to use this one, N2 by V minus N1 by U is equals to 0. In this value becomes 0 for the plane mirrors, and for the curved mirrors we have N2 minus N1 by R. So these formulas are very important for 1 marks and 2 marks. Understand, children? Now Okay, here we discussed about the refraction of light at curved surfaces, whether it is a convex or concave. For example, suppose if you take a transparent object which is bounded, the transparent object which is bounded by two surfaces. A transparent object like this which is bounded by two surfaces like this and like this. So, and these two surfaces are curved surfaces. At least one of the surface is curved. Then that transparent object is known as lens. Once again I am repeating, what is lens? This is important for 1 mark. What is lens? A transparent material which is bounded by two sides by the curved surfaces. At least one of the surface should be curved. It is not compulsory two surfaces should be curved, but at least one of the surface is curved. Here I wrote the definition once you see. A transparent material is bounded by two surfaces of which one or both are spherical. At least one should be spherical, and sometimes two should be spherical. And in this, that we'll call it as a lens. In this lenses, we have different types of lenses. Here in our textbook, they are given 5 types of lenses are given, that we'll discuss. What are that 5 types? Suppose if a transparent material is bounded like this, the two surfaces are bulging outwards. See, this surface and this curved surface, these two are bulging outwards. Then such a type of lens, we'll call it as biconvex lens. What we'll call? Biconvex lens. Convex lens means when the light falls on this, the surface is bulging. Here also when the light falls on this, the surface is bulging. So such a type of lens, we'll call it as biconvex lens. We'll call it as biconvex lens. Now, second type of lens. If the refracting surface is curved inwards, if the refracting surface curved inwards, then such type of lens we will call. See, this is inwards, and this and this also. Both the surfaces, when light falls and you find out the reflecting surface is the refracting surface is bulging or inward, or what you find out. Here the two refracting surfaces are inwards. So this is two or inwards means we'll call it as bi means two. So these are concave. Concave means it is having inwards the surface. So this type of lens we'll call it as biconcave lens. And the third one is, if one of the surface is a plane, if the refracting surface is plane and other one is bulging, we'll call it as a plano. And if the light falls on that, so on which surface the light is falling, so that surface we have to find out, that is bulging. So bulging means convex. So this is a plano convex lens. Now coming to this, coming to the fourth type. Here in this is also plano, and when light falls on that, the surface is inwards. So this is a plano concave lens. And here you see, when don't confuse, always how the two surfaces, when the light falls on that surfaces, the type of surfaces you find, whether it is a plane or bulging outward or curved inwards, then you can find out the type of lens. Here if the light ray falls on this curved surface, and this curved surface is, this curve is inwards. Inwards means concave. This is the concave, and this surface, when the light falls on that surface, this is bulging. So this is a concavo convex lens. So these are the types of lenses. And one time they asked about what is lens and draw the types of lenses. And draw the types of lenses. For the this question they asked for 2 marks. So what is lens? A transparent material which is bounded by two sides and bonded by two surfaces of which one or both are spherical. How many types of lenses we have? Biconvex, biconcave, and plano-convex, plano-concave, and concavo-convex lenses. And in this chapter, refraction of light at curved surfaces, we will discuss about only this 1 and 2, these two lenses only. What are that? Biconvex and biconcave lens. Simply we'll call it as convex lens and concave lens. And for the curved mirrors, we have some terms which are related to the mirrors. Now, for the lenses also, we have some terms. There are some terms which are related to the lenses that I will explain now. Suppose if you take convex or concave. For example, if you take convex lens, this is a convex lens. No need to write biconvex. By no need to use. Just simply you can call it as convex lens. And each curved surface, here there are two curved surfaces. This is one curved surface and this is the another curved surface. So each curved surface is a part of a sphere. It is a part of a sphere. So if it is a part of sphere, means that sphere has a center. The sphere has a center. So that will take it as C1. And for another spherical surface, this is also a part of another sphere. For this also, this surface also, or otherwise this sphere also has a center. That will take it as C2. That will take it as C2. If you draw a line which is joining from C2 to C1, if you draw a line joining from C2 to C1, and when you extend this line, this line is known as the principal axis for the lens. That line becomes the principal axis for the lens. And the C1 and C2 are the centers of this each curved surface of the lens. Next, here if you find out in this lens part, here the middle of this lens has thick and the edges it has the thin. If you take a biconcave, the middle one is the thin and the edges are thick. Whatever the lens, either it is a convex or concave or whatever may be, here for the lens it has a midpoint of the lens. For this middle in this, the midpoint of the lens, will call it as optic center. What will call it as optic center. Here for the mirrors, we have the center of the mirror is known as pole. But here we have to use a new term, the midpoint of the lens, that will call it as optic center, and it is denoted by the letter P. And these are the terms. We have to use in this chapter for the refraction of light.